I'm going to go over the first problem within this question to give you a sense of how to complete each part of it. But then I think based on that, you can figure out the rest of the problems. And if you still have questions, feel free to reach out to me or your teacher. So in this problem, we have two Ant-Man figures. And what the company wants to do is they want to make all the pricing proportionate. So we're dealing with our ratios here, and we have three-dimensional figures. So in the problem, it says the smaller figure uses 15.4 cubic centimeters of plastic, while the larger figure uses 240.625 cubic centimeters of plastic. So that's the information that we're given in this problem, and we're going to need to use that to access the information we want to answer our questions. So the question is, what is this information? Well, a few things give you a hint. One, it's talking about the plastic used, so that kind of refers to the structure of the shape. And also it says cubic centimeters. Cubic centimeters measure volume. So here, you're actually given the volumes of these figures. So we can say the ratio of the volumes of these figures is 240.625 over 15.4 for the bigger figure to the smaller figure. But to get at the information we want, we're going to need to simplify this so that we can more easily see what's going on. So if we simplify that fraction, it's actually going to be 125.8, or 125 over 8. And if you know your perfect cubes, you'll notice that these numbers are a lot easier to work with than the 240.625 over 15.4. So let's look at the first question now. The first question says the smaller figure is about 7.7 centimeters tall, which is labeled right here. How tall is the larger figure? So when we're asking for the height of a figure, is that measuring volume? Certainly not. Or area? No, that is a segment, a line segment. So that's a linear measurement. So we need to access the linear ratio for this problem to answer the question of how tall that taller figure is. So we'll take our volume ratio right here, 125 over 8. And to get the linear ratio, remember, we need to cube root that. And if we're going to cube root a fraction, we can actually take the cube root of the top, which is the numerator, and the cube root of the bottom, which is the denominator. And when we do that, you'll see it's 5 over 2. So 5 over 2 then is our linear ratio. So we can use this to get at the height of that taller figure. So now we have this linear ratio of 5 over 2. What we're going to do is we're going to set up a proportion. So the ratio is 5 over 2, and we're given that the smaller figure is 7.7, but we don't know the taller figure's height. So we're going to call that x. And here's where you cross multiply. So get the two arrows going from the top of the right to the bottom of the left, and the top of the left to the bottom of the right. So you're going to multiply across those arrows, and you'll get 2x equals 5 times 7.7. Doing a little algebra here, or just a little math, 2x equals 38.5, and then x equals 19.25. So that number right there would be the height of this taller figure. So we used the linear ratio, set up a proportion and cross multiplied, and then solve for x. So for each of the following problems, you're going to do a similar thing. The key is you have to figure out which ratio are they asking for. So just take a peek at the second one. If the surface area of the larger figure is 313.75, what is the surface area of the smaller figure? Well, it's pretty straightforward there. You're going to look at area, so the area ratio. So we have the linear ratio. To get the area ratio, you'll want to square both the numerator and the denominator, and then use that ratio in your proportion to cross multiply. As you go down further and further, you'll have to do a little bit of using context clues to figure out if you want the linear ratio, area ratio, or volume ratio. But you should be able to figure out once you know which ratio to use.